Hello, I'm David Karen.
I'm Tyler Vidusic.
And today we're going to talk about magnetic levitation and superconductivity.
Okay, so how can a magnet levitate over a superconductor? That's a great question. Nice job. Commonly, it was thought to be Lenz's law. Lenz's law is where there's induced voltage based on a change in the magnetic field over time. So, as you bring a magnet close to a superconductor, you're going to change the magnetic field. There's going to be an induced voltage, and because of the low temperatures and low resistances of a superconductor, there's going to be a very strong current that opposes the motion and levitates the magnet, which makes sense thinking about, but it's not actually the case. Wrong. What actually could happen is you could have this rare earth magnet on top of the superconductor, and when you cool it down, you could still make it float even without a change in the magnetic field. So in order to counteract that, we have
the Meissner effect. The Meissner effect is the real reason a magnet will levitate above a superconductor. So, unlike my associate over there who thinks Lenz's law is the way to go, the Meissner effect happens because when you supercool a superconductor past its critical point, it's described as excluding magnetic fields, no matter what. So even if there's a magnetic field already through it, it will be excluded. So what does that mean? That means that the superconductor will form a north pole underneath the magnet's north pole and a south pole underneath the magnet's south pole, thus creating magnetic repulsion. And now a very interesting thing with the Meissner effect is that since the conductivity is so high in a superconductor due to the almost zero resistance, these north and south poles that are induced in the superconductor will rearrange themselves almost instantaneously. So as we spin or move this rare earth magnet on top of the superconductor, the north and south poles will rearrange themselves with it, thus keeping levitation no matter the oscillation or spin of this magnet.
So now you at home may be thinking, how can I make a magnet levitate over a superconductor? And I'm going to answer that for you. First, you need a type 2 superconductor, and the one we have here is a yttrium-barium copper oxide superconductor. Just a piece of something, some alloy. You're not supposed to touch it with your fingers. The oils in your hands can interfere with the superconductor properties. We also have a rare earth magnet, really just a magnet made of rare earth metals. Pretty standard. This one's a little large. You're probably going to want smaller ones depending on the size of your superconductor. You're also going to need liquid nitrogen. Unfortunately, they don't really give liquid nitrogen to 20-year-olds on a regular basis. You need gloves to handle them. You need safety goggles. There really needs to be some type of supervision or understanding. So we can't actually do this right here, right in front of you right now. However, we did do it before in the inorganic chemistry lab, and we will show you our results now.
You can go get food if you want before class. I'm just going to roll up a little bit late.
Oh, okay. I was just going to see if the floating...
And then check the ball. Lost it. It's gotta cool down again. Alright. So just pause. Did you stop that one?
Oh, it's quite clearly levitating. Spin it.
I think I lost it.
No, there's still some.
I tried to get some rotation there. Yeah, that's fine.
Okay.
So that was cool. In those clips, we saw a magnet levitating over the surface of a superconductor. No matter any type of perturbation, such as spinning, moving, whatever, it stays at a distance for the most part.
Yeah, and I'm sure you're thinking to yourself, man, I wish I could do that all the time, not at 40 to 50 degrees Kelvin, which is necessary for a type 2 superconductor to display superconductive properties. So, if we ever find a room temperature superconductor, or even just a hotter superconductor than what we used in the video, you can imagine all the possible applications of something that can just cause magnetic levitation. Thank you for your time. I hope you enjoyed our video.
Please enjoy these pictures of Joe Avenoso.